Welcome to the Machine Learning at Home. So far, we used a simple table to understand about misclassifications which are resulted from the machine learning. However, it's always tempting to have something numerical, some number which tell us how well our machine learning went on. And for that reason, some time ago, I invented myself the function which is doing this misclassification table with some little more calculations of numbers which might be useful. So let us give an example first. So as usual, we'll make a train and testing data sets. Iris train from iris data, and this is a shorthand which I frequently use, 1 to 5 more than 4, and that will select every fifth row. Then we use iris test object to store all other rows which are results of negation of the same logical expression. Okay, now we need the MASS library to run a simple linear discriminant analysis. Library MASS. Okay, now I will simply make a prediction in one row. So iris PRED, I will shortcut it, and then I run a function predict, and within function I will run another function LDA with formula species against all other 4 characters in that case, and data is iris.train. And I also need to put in between these 2 parentheses the new data, iris test without 5th column, -5. Remove this bracket. Okay, sounds like I made it correct. Let us run it. Okay, and now we have result of our classification stored in object class of iris.pred. So typically we run a table, but now I will show you how to make slightly more than a simple table. For that reason, you should install my own package. I didn't find anything better than name package with my second name. So you need to run a function install packages, not the plural, Shipunov, SHIPUNOV. That's my second name. So well, this package is already installed on my system, so I don't run this command, but you please run it, and finally you will have that package installed. Now we can call it, load it, so with function library. It will tell you some version. My version is slightly newer than your version, logically, because I'm developing the package. But this is okay, and results will be different. So now we go and apply the function Misclass with uppercase letter. Apply it in such a way that predicted one will be first, and then we have initial species name of iris.test variable number 5, which was missed so far. We now will use it. So you see now how this table is slightly better than typical table we used so far. So it will supply you with names of everything, but it is not very advanced. What is interesting here is a mean misclassification error. So this is a reverse accuracy of the whole classification learning process. So accuracy, of course, should be 100%, and reverse accuracy is 0, when the process went very well. And these three numbers are specificity. So each species is predicted with some specificity, and you can see, for example, here, then where the color is predicted with specificity reflected in 12.5. To be more precise, this is again a reverse specificity. So specificity is 100% when everything is predicted correctly. So in that case, the more specificity, the less correct is prediction. But you understand the sense of it, and now you can use these numbers to understand what's going on with each of your species. So since I am a creator of Misclass, I tried to make it very flexible. So it now, like in some ways at least, overrun analogous functions available in some other R packages. To demonstrate it, I will move to another field of machine learning, or in big data mining field. So far, we used some training process to understand and build a model which will finally apply it to our testing subset. That was a main principle. But that principle is not carved in stone. There might be different approaches. For example, one of approaches called multiple names like clusterization or non-supervised learning, and I prefer to call it layout learning. And this process will establish clusters, names, you can say that, out of nowhere. So it will look on data itself, of course without species variable in our case, and try to find out what are possible species names in this data. It's very interesting. There are many different ways to do it. So again, as a whole, they typically called clustering, clusterization, or non-supervised learning, and I again call it layout learning. So one of the first methods of layout learning I like to present is a k-means. So k-means is not so far, by the way, from KNN, but it uses a different principle. So let us run k-means, because the function k-means is embedded into base R. You don't need any package for that. Simply use it. So k-means from our iris data, and we do not split data now into training and testing subset, but we should omit the column with the species name. And now the only thing which we need to supply to k-means is a desired number of clusters. We know that there are 3 species, so best is to say centers equal to 3. And of course we should write this result down in some objects, for example iris.key. Okay, we did it. And now what is going on? Iris.key object contains multiple different sub-objects. So for example, there is a cluster component which contains what system, what algorithm found to be our new species. Look on them. They are numbers. Logically, of course, because this algorithm doesn't know anything about species. We didn't tell it species names. We omitted species column. Then what is 1, what is 2, what is 3? It's hard to tell, but it probably corresponds somehow with our species. And now one of the good features about Misclass function, it can construct so-called best classification table out of this like nameless 1 to 3 vector. So let me show how to make it. So we should run Misclass in a similar way, but we should use iris key cluster as a predicted something, and iris variable number 5 as our actual species name, observed species name. but also must specify option best equal to true. By default, this option is false, doesn't work, but we need it to work. So what is going on? The function will combine species with 1, 2, and 3 to find out which of this combination works the best. What is actually 1, what is 2, and what is 3. So this is how the function works. So now, as you see, this is the best classification table. And as you see from that table, 1 corresponds with Setosa, 2 with Virginica, and 3 with versicolor. So it's not exactly the initial alphabetical order. Species are changed. So by default, versicolor is always first, but in this table, versicolor is second after Virginica. So this is important to understand. This method uses all possible combinations to understand which combination is best. It's not ideal method, but it will show you how this non-supervised clustering layout learning works. So far, I didn't see any analogous approaches in R. So you can even see that there is a 10.7% of reverse accuracy or mean misclassification error. And this is very good because remember, this function does not know species at all. It found them itself. It's fully agnostic to the species names. So that's very good, perfect results. Well, of course, k-means have some downsides. For example, it is stochastic, but you can make it more stable. It also not absolutely agnostic. So I just would like to ask you a question, and we'll make a pause and you will think how to answer it. Then I will answer it myself. So why k-means is not fully agnostic? I think it is not fully unsupervised method. We tell something to k-means. What is it? And this is my answer. So we tell how many species are in our data. So we told this function they will have 3 species, and that was very important information. Without number of species, k-means algorithm cannot start. So we must tell it. So we should still help algorithm to work better. Interestingly, there are methods which allow you to find what is possible number of clusters, number of groups in your data. So there are some R packages and methods which allow you to do that. And if we have time, I will probably show how to do it fully automatically. But still, there is a way to tell k-means how many species we want. So it's not exactly fully automatic, unsupervised way. That's, by the way, one of reasons why I call it layout learning. All right. So this is what I wanted to tell today, how to use Misclass function and what is clustering, unsupervised, non-supervised learning or layout learning. Thank you very much.